Hi everyone, welcome guys. Can you please comment on if you can hear me and if you can see the screen? I hope you guys are having a good day. Please confirm, guys. Please confirm if you can hear me, guys. I'm waiting for your confirmation. Okay, thank you very much. So I want us to wrap up this trigonometry part 2. We're going to work on trigonometry 3 dimension. This is what we currently did last time. So we're just going to go straight into questions. This is the diagram that I have, and on this diagram the first question wants us to find this is the diagram. Most of the time on the statement they just tell you what you see on the diagram, so I'm not gonna stress much about the statement, because we can see that the line AC, this line AC, it's equals to BC. That's what we can see. So this will also be 22.3 meter. Okay, I can see that. Then what I'm going to do, we can calculate the following. So number one, we need to calculate number one, the area. We need to calculate area of triangle ABC. So you need to understand where is ABC. So this is my triangle ABC here. I need to find the area of that triangle ABC. What are we going to do? Remember, we said to find the area, I'm just gonna write the formula for area down so that everyone can remember which formula do we use. So we said the area of, I'm just gonna, okay, so this will be the area of triangle ABC. The formula that we're going to use, it's half. This will be, let me look at the angle there. We're going to use angle C. So this will be AB, the sine of angle C. Right. We're going to use small b, and then we're going to use small a. Why? Because the angle should be the included angle. So the two sides that are given, it's A and C, then we use the included angle. That's the most important part. That is the most important part. So what we are trying to do is that this can be written as 1/2, and my small a is the length of BC that needs to be multiplied by small b, which is the length of AC multiplied by the sine of that angle C. So this is the area rule. The only thing that you need to do, you need to substitute what you are given, because now on the statement they told us that AC and BC are equal. So I'm just gonna do the substitution and say this is 1/2. Where there's BC, I can put 2.3. Where there's AC, we can put 2.3. This is the sine of that angle C, which is given as 50.8. degrees. So now what I can do on this one, I can just punch what I have on the calculator and see what I get. Né? I can just punch this on the calculator and then we can see what we have, guys. I'll be waiting for your comments. Né? I'll be waiting for your questions. I need you guys to ask questions because I think this will be the last time we do 3 dimensions, so you guys can see that we are pushing. So after 3 dimension, we're going to start Euclidean geometry. So remember, especially if you are writing, you need to make sure that you understand these concepts. Né? Right, so now when you put this on the calculator, we get this is 1/2 into 22.3 into 22.3, the sine of 50.8. What is the answer? We get 192.7 units squared. 192.7 if we round it off to 1 decimal place, but if you want to round it off to 2 decimal place, it's fine. You can also round it off to 2 decimal place. Né? Right, because I think most of the time in an exam they'll say round your answer to 2 decimal place. So when you round your answer to 2 decimal place, what do you get? This will be 192.69 units square. So this is the area of triangle ABC. I hope everyone is happy with that. Eh? Thank you, guys. Let's push the stream. Let's tap the screen, guys, please. Tap the screen. Eh? Thank you, Ndongizota. Thank you. So that was the first question. Let's look at the next question. Let's say we need to find the length of AB. Calculate. Let's calculate the length of AB. Look at this. The length that you are looking for is the length of AB. So I'm just going to highlight that length so you can see which length are we looking for. This length here. We are looking for that length, which is going to be my small c. It's my small c because it's opposite to that angle, and I have 2 sides. So this tells you that we can use the cos rule. Okay, we can use the cos rule to find the length of AB, and the formula that we're going to use is going to be c squared, which is the side that we are looking for. So it will be 6 squared. It's equal to, then we add the 2 sides, a and b. So this will be a squared plus b squared. We minus 2 of AB times the sine of the included angle, which is angle C. I'm sorry, this is not the sine rule, this is the cos rule. Né? So this will be the cos of what? This will be the cos of that angle C. Okay, I'm happy with that. What can I do from here? What can we do? What is C? We know that C is AB, which is what we are looking for. This will be my AB squared. It's equals to small a is 22.3, and this should be squared. We add this to b, which is 22.3, and this is squared. I'm going to minus 2. The value of a is still 22.3 into 22.3. I don't want to say too much details. I don't want to confuse you guys. So the cos of angle C, look at what is angle C. That's 50.8 degrees. So we need to punch that on the calculator and get what is AB squared equals to. Then that's when you can square both sides. Né? That's when you can start by squaring both sides. I hope everyone is happy with that. Né? So if I put this on the calculator, let me see what I have. Squared 22.3, and it's also squared minus 22. 22.3, the cos of 50.8. This gives me 365.9762, ne? So 365.97 what. So now if we round this off, I need us to square both sides so that we can find the square root of answer. So AB is equal to the square root of answer, it's 19.13 units. So this will be 19.31 meter. So here we were supposed to say, remember it's given in meter, we're supposed to say our unit is meter squared, which makes this one 1.31 meter. That's the length of AB. So if you have the length of AB, that's good, ne? Right. Do we have any questions on this one? Thank you, Ntombi Zotwa. What happened to other learners, guys? There's only Ntombi Zotwa. Are you guys listening, man? Oh, Tandy. Okay. Moving. I'm here too. Okay. Okay, I see you guys. Let's work on this, because now it's very important that you understand what we are currently doing. These are just warm-up questions. We're going to move to a past paper, but on a past paper we'll work on this type of questions, don't worry. So now let's work more on these questions before we can go to the past paper. Look at this. Now I think we can also find the height of the tower AD. Look at this. We can find the height of this AD. But now, let's say this was 2 marks. What are you going to do? Because if it is 2 marks, this tells you that this should be easy for you to do. What are you going to do? How can we find the height of AD? I just want you guys to tell me. Calculate the height of the tower. So we are looking for the height of AD, and this is just simple 2 marks. I need to see what can you do if you want to calculate the height of AD. Can someone please tell me? Because look at where's AD, and this is 2 marks. So the 2 marks tells you that this should be easy. And then what are you going to do? How are you going to calculate the height of AB? Which triangle are we using to calculate AB? And Tomizotwa, can you please maybe try to check in which triangle AD is? Look at this triangle AD. I mean the line AD is a common line between 2 triangles, which is AD and ADB, and also ADC. So it's a common line. So we can use, look at this, you know what I'm going to do? I know that it's a common line, but if I use ACD, I don't have this angle here, which is going to be a problem. But if I use ADB, then I can use that angle, it's fine. So this tells me that someone is saying sine, someone is saying that we can use sine. Okay, let's see if this is true now. So what I'm going to do, I'll say that I'm looking for this line here. I'm looking for this line, and then I'll focus on this triangle. I'll focus on that triangle now. So if you still remember, we just calculated this, and what was this equals to? We just got 19.31. So this is my 19.31. This is the length of AB, and I'm looking for that guy. So can you see that I have opposite and adjacent? I have opposite and adjacent. So I'm just going to write it down and say the SOH CAH TOA. So this, it's opposite and adjacent, we're going to use tan. So the tan of that angle, which angle are we using? The 25.4, the tan of that angle. So this will be the tan of 25.4. Thank you, Ngube. We use tan. So this will be the tan of 25.4 degrees. We equate this to opposite, which is my AD, all over adjacent. We just calculated the adjacent as 19.31. If you can manage to get to this point, therefore you can just make AD subject of the formula. You can just say, I'm going to multiply both sides. We need to multiply both sides by what? By that 19.31, meaning that we need to get rid of, we can say this is 19.31 and this will be multiplied by 19.31. Therefore, now I'm going to say my AD is equals to 19.31, the tan of 25.4 degrees. Whatever answer you get when you punch this on the calculator, it should give you the AD. This is easy, no? Right. So this is 19.31, the tan of 25.4, and this gives us 9.17 units. So AD is equals to 9.17 meter. Exactly, Tandy. Thank you very much. Ne? That's correct. Thank you very much. That's correct. So now let's calculate the length of DC. Okay, this will be question number 4. Calculate number 4. The length of DC if D angle BC is equals to 67.3 degrees. How can we calculate the length of DC? I'm just going to check and see where's my DC. So the length that they are looking for is this length. We need to calculate this length if we are given A angle or D angle BC. D angle BC. So the angle that they are referring for is this one, and then it's given as 67.3 degrees. So I'm just gonna remove my triangle DBC, BCD. I'm just gonna isolate that triangle, remove it, and I'm just gonna put it here so that it can be easy for me to work out on this problem. Ne? So the triangle that you are currently working on is this one. So this is my B, and I have this as DC. So remember, it is given that this angle here is 67.3, right? That's my angle. Now look at this. Remember, we know that angle D was given as 58. Now I'm just gonna put this as 58. This was 58.6 degrees. So that is my angle. So if I go back up, this is what I did. I just removed my triangle, then I put it down there. Now this length BC, we know that it was equal to AC, which was 22.3 meter. Now we just calculated DB. Did we calculate DB? Do you have the length of the line DB? Nope. we don't have DB, we are looking for DC, né? So I'm just gonna name my triangles like this. Please pay attention. The side opposite to this will be small b, the side opposite to that will be small d, and the side opposite to this angle will be small c. So I'm going to use the sine rule to calculate this this thing. I'm just going to use the sine rule now. So if I use the sine rule, I'm going to say small b over the sine of that angle b. This will be equals to, so now I can't use this side because I don't have the side and the angle. I need to choose this other side because remember, we are looking for small b. We can't choose this side because we don't have the angle and the side, but we need to choose the one that has both the angle and the side. So this will be small d all over what? The sine of that angle d. So if we substitute small d is DC, which is what we are trying to calculate, and this is the sine of angle b. What is angle b? This is just 67.3 degrees, and then we're going to equate this to d, which was given as 2.3, everything divided by the sine of that 58.6 degrees. So what's next? We need to cross multiply. Say DC will be multiplied by the sine of 58.6. Equate this to 2.3, the sine of 67.3 degrees. So when I have it like this, what can I do now? I can just isolate DC. If I have DC, the sine of 58.6, this is equals to 2.3, the sine of 67.3 degrees. So I can just divide this side by the sine 58.6, divide the other side by the sine 58.6. So these two guys will cancel, and now when you punch this on the calculator, you should get the length of what? The length of DC. So DC is 2.3, the sine of that 67.3, and everything divided by the sine of that 58.6. So when you put this on the calculator, what do you get? .10 meter. Thank you. So this will be 24.10 meter. So I just want to attend to your comment in Nube. Nube is saying we must first get dB and BC, then we use cosine. I think if you do it like that, it depends on the mark allocation, but if there's not much marks, maybe this is the method I recommend you use. Né? So if there's no too much mark allocations, please just stick to this method. Né? Tandy, thank you very much. I can see your answer. I'm trying, guys, to move slow. Né? I'm trying to move slow. So if you still remember yesterday, né? If you still remember yesterday, we worked on the type of a question like this, but I'm not gonna do the same question. I'll do the different question, and this question is the one that will help us to do a past paper. Né? So meaning that if we can understand this question and if we can be on the same page with this one, everything will be good. We can work on past papers. Okay, so look at this now. Let's say I have a triangle like this, and then let's say, okay, let me fix this. Okay, so this will be okay. So yesterday we did this type of question. Let's try to change it and then let's call this angle beta. Okay, I'm just gonna write this right now, don't worry. Going to call this beta, and then I'm gonna call this theta, and then let's call this angle alpha, and this is my 90 degrees. This is P, this is A, I have B, and then this line here is C. The length of BC is given as 20. So this is the only information that you have. This is the only information, and the first question, number 1, they want us to write AP in terms of AB and alpha. Remember yesterday we said that, I get you saying, oh no problem, thank you very much. Remember that yesterday we talked about that if they are looking for AP, we need to check in which triangle it's AP. So look at this. This is my AP, and if this is my AP, they said we need to include AB in our formula. So we are looking for AP, which is my opposite. Now they say your answer should have AB. I'm going to underline that AB so that I don't forget to put it on my answer. So this will be my adjacent. Because I'm using this angle, I need to have alpha on my answer. So look at this. To answer this question, I can say that I have the SOH CAH TOA look at the tan. It's opposite over adjacent, which is the one that we need and the one that they want us to use. We are trying to calculate AP, and we should have AB on our answer. So the best thing to say is to say that the tan of alpha is equals to opposite, which is AP, over adjacent, which is AB. Then when you write this, you just have to isolate AP, remove everything this side. We can multiply this side by AB, multiply the tan of alpha by AB. The answer that you get is your AP, and then what is your A? Not your AP, not your AB, but it's your AP. Then when you put this, the AB cancels this side, you are left with, you see now. Okay, so this will be AP, it's equals to AB, the tan of alpha. Then you are done. This is the end. We've expressed AP in terms of AB and alpha. So this is your answer. So somewhere we're going to need this answer. Somewhere I know that we will need this answer. I hope you guys are with me on that. I hope you are on the same page. Then we've successfully answered the first question. Okay, sir, please record the session. I'm leaving the live. I have to go to school. Don't be zot, but this time I thought everyone is coming back now. I thought everyone is coming back now. Okay, so let's work on the next question. That was the first question, and the first question wanted us to write AP in terms of AB and alpha. So number 2, we need to prove, this is exam type question. It's from the past paper. Prove that AP is equals to 20 the sine of beta, the tan of alpha, over the sine of theta plus beta. Okay, so when you see this type of question, this is where most learners start to panic and do all the stuff. You know what I need you to do? Please don't stress, okay? No need for you to stress. Just analyze the question, make sure that you understand what is the question saying. The question wants you to prove AP. But remember, even though they want you to prove AP, we already know what is AP equals to. We know that AP is equals to that guy, it's equals to AB, the tan of alpha. So now look at this. So far we have the tan of alpha. We just have to calculate the length AB. So hopefully when we calculate the length AB, we come back and substitute this here on AP. We should get this answer. I hope everyone understands that part, right? So I'm going to check in which triangle is AB. So AB is a common line of the two triangles. It's a common line of the two triangles. But now I'm not going to focus on APB. Why? Because already I have alpha. These angles only bring alpha to the party. So I'm not going to focus on that triangle because I already have the alpha. So the triangle that we need to work on is ABC. Right, I'm just going to write it down. And to solve this, I'm going to say, okay. To solve this, I'm just going to say, in triangle ABC, we are looking for AB, so I can say this is AB over the sine. Which angle are we using? Because if you are using AB, the opposite side to that AB is this one. So we need to use the angle of beta. So this will be the sine of beta. Then we're going to equate these two. Look at this. We have AB because we are looking for AB. We have it on our equation. Now we need to choose a side and an angle that we need to include in this, and which one is the best. I'm going to choose this one because I've already given that as 20. I've already given that as 20. So this will be BC over the sine of the angle that is opposite to this side is that angle. So what are we going to call that angle? Maybe we can call it B angle AC. I hope everyone is with me on that. We are referring to that angle, but we don't know what is that angle equals to. That's my problem. We don't know what is that angle equals to. So you need to ask yourself, how can we find that angle? So to find that angle, we can use sum of angles in a triangle. We can say that in triangle ABC, angle in triangle ABC, we are looking for angle BAC. This angle is equal to 180 degrees. We minus the sum of what? The sum of these two angles. We need to minus the sum of these two angles. So I can write this as minus into theta plus beta. Now I can celebrate. Can you see that we're almost getting what we are looking for? So this tells us that the angle of B angle AC is equal to 180. We minus into theta. I'm just going to leave it like that, né? Plus beta. So now what is this equal to? Let's substitute everything that we have, né? I hope I'm not moving fast. Let's just substitute everything that we have. Okay, please give me a second. All right, so look at this now. This is nice. I know that AB is what I'm looking for, and then I'm just gonna write this as AB over the sine of angle beta is equal to BC is given as 20. This is divided by the sine of that angle, which is 180 degrees, minus inside the bracket theta plus alpha. I hope everything is good so far, né? I hope no one is lost. We just calculated the angle and we substituted the angle. Now we can do what we call the reduction formula. We can do the reduction formula and say if we do the reduction of formula, let me see what I have here. I'm going to say the sine of 180 minus theta plus beta. This is what? This is in quadrant 2. How is sine in quadrant 2? Sine is positive, so we can write this as positive. The sine of what? Positive the sine of that angle, which is beta plus theta. Yes, now I can celebrate. I know that I have the sine of theta plus beta. You see, everything is good so far. I can just do my reduction formula. I can just write this as AB over the sine of beta. It's equal to 20 over, and then I know that when we reduce this, we get the sine of theta plus beta. This makes sense, né? Now we can cross multiply and say AB, the sine of theta plus beta, this will be equal to 20, the sine of beta. Then now we need to calculate for AB. We just have to isolate AB by dividing both sides by that sine of theta plus beta. Therefore, AB it's equals to 20 the sine beta. Everything is divided by the sine of theta plus beta. That's my AB. And remember, we are trying to calculate the length of AP. So we know that AP is equal to AB the tan alpha. I'm just going to substitute that and say my AB it's equals to, not AB, AP. AB the tan of alpha. So let's substitute our AB. We know that AB is equals to 20 the sine beta divided by the sine of theta plus beta. Okay, so far so good. We're multiplying this by the tan of alpha, which is over 1. Then we can just row multiply. When we row multiply, we get our AP to be 20 the sine of beta, the tan of alpha divided by the sine of theta plus beta. Right, you see, we've managed to prove what they wanted us to prove. Remember, the question said prove that AP is equal to 20 sine beta times tan alpha. So what you need to do, first thing first, just follow the question. So let's say they did not ask you this, né? So you can see that this is where you were supposed to start. You were supposed to start by finding your AP first. You guys have any questions on this one? Do you guys have any questions? I'm waiting for your questions, guys. It was gonna be nice if we have multiple questions. Everything is good, né? Okay, let's try to answer this one, né? That will be the last question for this one. Let's say this will be number 3, question 3, né? Number 3. Remember, I'm saying this is from a past paper. Let's say they say we are given that AB, which is the one that we calculated, is equal to AC. So now determine in terms of alpha and beta in its simplest form. I'm not sure what they are asking for here, but let's try to to analyze the question. Let's try to analyze. They say that we are given AB. We know that AB is this one, and it's equal to AC. Let's go back to the diagram and see what is AC. It's equal to AC. Oh, they say this is this AC, this line. They say AB and AC are equal. Okay, we can see that. That's what we are given. Determine in terms of alpha and beta in its given form. What's going on, guys? We are given that AB and AC are equal in terms of alpha and beta. Oh, determine AP. Determine AP. Because this question was not making sense. They want us to determine AP in terms of alpha and its simplest form. You know when I have this type of question and they say, look at this, guys, look at this. I'm just gonna try, because I think we need to focus on this part. We need to focus on this part. Please, guys, forgive me if I'm thinking. Remember, most of my lessons, I don't refer to memos, I don't refer to memorandums when I teach. I just think, because I do this every day and I always get most of the questions right. So even if you can check on my TikTok, there's someone who commented, I made a mistake when I was doing that solution, and it's also on YouTube. The video is also on YouTube, and I've made a mistake, but I did not notice the mistake. So someone commented about that mistake, but it's fine. We'll go and fix the issue. So when I think about this type of question, I'm just gonna go to my diagram and see why they are saying AB and AC are equal. What is the aim for them to give us the statement? Because this is where you need to start. Understand their aim. Why are they doing this? How can this statement help us? Let's go and say AB and AC are equal. So if this is AC, we're definitely going to need a different marker here. If they say that this AC, okay, and then this AB, what? This AC and this AB are equal. Oh, you see now? Look at this. They want us to determine AP in its simplest form. So they are trying to say inside this bracket, just say theta plus theta, or say beta plus beta, then solve. Okay, I'm not going to use theta because I don't have beta on top. Look at on top, I have beta. So I need to write this as the sign of beta plus theta. Let me explain why they gave us that statement. Look at this. If these two lines, if this line and that line are equal, what is this telling you? They're saying that this angle is equal to that angle, base angles of a triangle. So we can substitute the theta as beta, or we can substitute the beta as theta, because these two angles are equal. But I'm not going to use this one. I'm just going to substitute theta as beta. Why? Because look this on top. I have beta, so if I substitute that, I can cancel whatever sign that I have on top. Let's go and work on this. Let's go and work on this. I think we agreed that where there's theta, we can put beta. Baseline, the fact that you guys know this makes you, all the answers are wrong. I'm not sure what you are referring to when you say all the answers are wrong. I'm not sure what you are referring when you say all the answers are wrong. Which answers are wrong? Receptal. Please try to explain. I'm listening. So now what I'm going to do, I'm just going to substitute the theta as beta. So let's do that. So I'm going to say my AB let's rewrite this down here, then we're going to solve it step by step. So AP it's equals to 20 the sine of beta times the tan alpha, then I can write the bottom as the sine of beta plus beta, and then if we add those two, we're going to have this as 20 the sine beta times the tan of alpha, and everything is divided by the sine of 2 beta. So can you see that this gives us the double angle for sine? This gives us the double angle for sine, meaning that we can change the bottom and use the okay, we can change the bottom. Let's do this. We know that if I have the sine of 2 beta, I can write this as 2 sine beta the cos beta. So we can see that if we change this, it's going to be 20 the sine beta multiplied by the tan alpha, and everything is divided by 2 sine beta times the cos beta. So now I can see that this cancels, and then remember 2 goes into 20 how many times? 2 goes into 20 how many times? 2 times. So this will be, 10 times. So this will be 10 multiplied by the tan of alpha over the cos beta. So now look at the angles. The angles are different. There's nothing more we can do. This is where we're going to stop. So we've managed to simplify what? We've managed to simplify AP to its simplest form. And that's it. Receptal, I'm still waiting for you to tell me what do you mean when you say all the answers are wrong? Which answers are wrong? Okay, I guess I'm just gonna block you. Alright, so now that's it. We can move to the next question. Nomtebo, I see your comment. I see your comment. Okay, so now let's keep on working on exam type questions. Let's keep on working on exam type question where we need to add or subtract 2 or more angles. Then we can see a pattern. Maybe we can just start with an easy problem that we can practice. Okay, let's do most of the ones that you're going to get on an exam, which they have to do with okay, Nomtseb, I can see your comment, don't worry, we'll definitely post the recording. So if I have something like this, okay, let's try to work on the question that has to do with proofs, where they'll need you to prove something, and then let's say okay, so this will be my C, this is B, and I have this as A, and we're going to call that point D, and then the height is H, and this is my 90 degrees. I have this as alpha, this angle here, I have this as beta, that angle there, and then we have this whole angle here. Maybe we should put it with a different marker. Eh? This whole angle here is given as theta. This whole angle, please guys, the angle is not only for that small, it's the whole angle. Let me just put it like this now and say this will be theta is this whole angle, right? So let us prove that the question says show that h it's equals to be the sine of alpha, the sine of theta, and everything is divided by the sine of theta plus alpha or plus beta. Guys, you see, when I have this type of question and I see it like this and I'm in an exam and I'm sitting in an exam and I see a question like this one, what am I going to do? What is the first thing that comes in your mind? Because the most important thing about solving these math problems is for you to know where to start. Thank you guys. Let's push the live. Let's tap the screen, please. Let's like, man. Right, so if I have this type of question, what I need you to focus on is the starting point, where you need to know where you should start. That's very important, né? Where you should start. Look at this. The most thing what I'm gonna do first is to start by finding what we call h. I need to know what is h equals to. So in which triangle is h? Look at this. The h is this line here. You see, that is your h. So this h is a common line between two triangles. So choosing the triangle that we work on is also important, because if I choose ADC, there's nothing I can do. There's no enough information in ACD. We don't even have an angle in ACD. In ACD, we don't even have an angle. We only have a side. So I need to choose the triangle that has at least a side and an angle. So the triangle that can work is this one here. So this is the triangle that we need to choose. We need to use ABD to solve for h. That's the start. Once you solve for h, you're going to know what is your next step. So I'm going to use that triangle to solve for h. So now look at this. ABD, it is not a right angle triangle. The 90 degrees is not on ABD, so we can use the sine rule. I repeat, the 90 degrees is not on the yellow triangle. It's not on the yellow triangle, so we cannot use the trig ratios, but we need to use the sine rule. Okay, so I have AD. I'm going to use my AD, which is my h, divide by, so if I use this, I need to use the side that is, okay, let's do this. Please pay attention. We are using AD. The angle that we use is the one that is opposite to that AD, which is the sine of alpha. So I'm going to say this is the sine of angle B. Let's call it the sine of alpha. The sine of alpha. And then we're going to equate these two. Now I need to choose another side that I can work on. And then now, what can we do? Because if I have something like this, I can find, I know that, okay, on the statement, there's something that is given there. On the statement, they're saying that angle AD angle AC. D angle AC is equals to D angle AB. Oh, this angle also is equal to 90. Okay, this angle also is equal to 90, but still I'm going to use sine. So this angle also is equal to 90. Let me put this right here. Okay, so I have this as 90, we have this as 90. So this will be, if I have that angle, I can use BD on top. I can say this is BD over the sine of that angle that is opposite to that side, which is angle 90. So I'm just going to put this as 90 degrees. Right, I'm just going to put that as 90 degrees. Okay, so far so good. So far so good. We can just substitute and say on top we have AD as H over the sine of alpha. It's equals to BD. I'm just going to leave it as BD over the sine 90. Okay, so let's make H subject of the formula. We cross multiply. This will give me H. The sine of 90 degrees is equals to BD, the sine of alpha, when we cross multiply. So what's next? We can just divide this side by the sine 90, divide the other side by the sine of 90. So what is H equals to? So H is equals to, the sine of 90 is just 1, but let me confirm that. Sine 90, I remember from the graph, is just 1. So this will be BD, the sine of alpha. Okay, so so far we have what? Okay, so this is my H. I need to find what? I need to find BD. I need to calculate BD, because whatever I do, I need to bring theta. I need to bring theta. So now the next thing, look at this proof. We need the sine of theta. So whatever that we do, we need to use a triangle that has theta. So we don't have a choice but to focus on this triangle now. On this triangle, to find BD, we need to use that triangle, the red triangle. That's the one that we're going to use. This is the one that we're going to use. Okay, let's do this. Let's work on this. So I'm going to say, if I use that triangle, I will say BB, BD, which is what we are looking for, all over the sine of the angle that is opposite to that side, and that angle is theta. So this will be the sine of theta. It's equals to, and then now we missed something. BC, the line BC was given as B. So that's why they want us to prove that this is B, the sine of theta. So that line was given as B. No, Tandy, I did not forget the over sign. This sign here, it's equals to 1. It's equals to 1. Even if you punch it on your calculator, you'll get that one, it's equals to 1. Yeah, you'll get that it's equals to 1. So now BC, it's what? BC is small b. So I'm going to say this is equal to BC, everything divided by the sine that is opposite to that one. Let's find this angle. We need to find this angle. How are we going to find that angle? The sum of angles in a triangle. Remember, I have theta, I have beta. So to find that angle, what are we going to call that angle? We're going to say this is B, okay, C, angle D, B. It's equals to 180 degrees minus the sum of theta plus beta. We minus the sum of this angle and that angle, the sum of these two angles. So now if we do this, we know that this will be just the sine of, inside the bracket, that angle is 180, we minus theta plus beta. Okay, I think everything is good now. I think now we can continue working on the problem. So let's substitute. We are looking for BD, remember? So this part I'll just leave it at the sine. I'm just gonna leave this as BD over the sine of theta. It's equals to BC is given as B over, what do you get if you reduce this? This is just the sine of theta plus beta. If you reduce it, you'll get that. So this will be the sine of theta plus beta using the reduction formula. Where is sine of theta plus beta? Quadrant 2. How is that in quadrant 2? It's positive, so this will just be the sine of that angle. When we cross multiply, this will give us BD, the sine of that theta plus beta, and then let's equate this to be the sine of theta. So the aim is to calculate BD. We just have to divide both sides by that sine of beta. So we have this as BD to be the sine of theta plus beta, and this is equal to B, the sine of theta. So I can divide this side by the sine of theta plus beta, divide this by the sine of theta plus beta. What do we get? B. D is equals to B sine theta over the sine of theta plus beta. Nice. So remember, our H was given as B, D the sine alpha. So we know what is BD is equals to. So H will be equals to, where there's BD, I'm going to substitute B, the sine of theta over the sine of theta plus beta. Then this is multiplied by the sine of alpha, which is over 1. Then we row multiply this. When we row multiply, we need to get the answer that we are looking for. Remember, we are trying to prove that H is equals to that. So when we row multiply, we just have to substitute everything, and this will give us H is equals to B, the sine theta, the sine alpha over the sine of theta plus beta. Right, I'm not sure if you guys understand the aim here. I'm not sure if you understand. Maybe someone can tell me, what did you learn so far about the trig ratios? What did you guys notice? What's going on here? What did you notice? Because there's one thing that you need to notice. Once you get that thing right, there's no way you're going to get this type of questions wrong. Look at this. What I need you to focus on, if they want you to show something like this, first thing first, you need to find what is H. Once you find what is H, this is exactly what we did. We calculated H to be this. Then you're going to have a direction. The next thing that will tell you is that, you know what, find BD. You need to calculate that. So the most important thing is for you to check what is the question saying. If the question says show that, whatever that they want you to calculate, first find that H, and then when you look at it, use the triangle. When we find H, we use the triangle that has enough information. I hope this makes sense, né? I hope everyone is happy with that. Okay, let's try to find a past paper and see what we can do from a past paper, how they ask this from. Remember, even this one is from a past paper, but we can try and look for a different past paper. Let's see what we get. So I'm just gonna look for a past paper. Even if we get, let's quickly Maths grade 12 past papers. I'm just gonna go straight to Department of Education. Let's start with the sub exam. Let's look at the past paper, then we'll try to answer that past paper. This is maths. This is paper 2. Okay. We need to open this using this one so that we can be able to write. I'm not sure if we're gonna write on the past paper or what, but oh, thank you. Let's see what we have here, then we'll try to answer the question. Okay, this is 8 marks. This is 8 marks, and we're just gonna work on it fast. Then we are done. We go and get another one. We go and get another past paper. So most of the time I don't focus on the statement, because the statement just tells me what I see on the diagram. I'll just go straight to the point and solve this problem. Okay, so when I look at this, what is the first question saying? Determine AB in terms of P and Y. So remember I said that we need to first check in which quadrant it's AB. Please guys, this is very important. This is very important for you to check which quadrant it's AB. So now, not quadrant, which, okay, let's do this. This is the AB that they are referring for. This is my AB. Right, this is my AB, and look at what is the question saying. The question says that determine AB in terms of P and Y. So now, where is P and Y? P and Y are in the triangle ABD. Now you know which triangle you need to work on, you see? Because P and Y, they are in this triangle. So we know that the triangle that we need to work on is ABD. This is my triangle. And then look at what I'm going to do. I need P on my answer, and this is my opposite because we are using that angle. Then this will be my adjacent. So according to SOH CAH TOA, we need to choose the one that has O and A, which is the tan of that Y. The angle is Y is equal to opposite, which is P all over adjacent, which is AB. So now we just have to make AB subject of the formula. I'm just going to multiply this side by AB, multiply the other side by AB. Then I'll have AB, the tan of Y, what is this, equals to P. But we are looking for AB. We can just divide both sides to find AB to be P. Everything is divided by the tan Y. So this is my AB. And then when it is like this, then this tells you that we have successfully answered what? Question 8.1. So this is my 8.1, and I know what is AB equals to. I hope everyone is happy on that. That was easy. Remember, normal trig ratios. Let me see your comments. Use right angle triangle. Normal trig ratios can be, yes. Once it's a right angle triangle, we can use the SOH CAH TOA. It needs practice. Yes, solid, that's correct. We just have to keep on practicing. We just have to keep on practicing. Okay, so now let's look at what we have on the next question. Show that cos x is equals to tan x, and this is 4 marks. And I look at this question, I can see that normal, this question is not making any sense. They just want us to prove that cos x is equals to tan y. Why they want us to do that? You know what I'm going to do? I'm going to look at my x, which is the angle. It is in that triangle. I can see that, and then I have the tan y. In which triangle is tan y? Guys. Look at how I answer maths question. I told you some of the questions I don't know how to answer them, but look at how I analyze the question. Please move with me. You're going to see I don't know the answer for 8.2 because I think everyone, you guys just saw, we just downloaded this now. I don't know the answer, but this is what I'm going to, this is how I'm going to analyze the question. They want us to prove that cos x is equals to tan y. And I know that this has to do with 3 dimension, and then I know that the x is this one, so I need to work with this triangle, like this triangle ABC. This is the triangle that we need to work on. So if this is the triangle that we need to work on, what more do we need? We need the tan y. I'm not going to stress about that because I know that I have my tan y here, which is also part of AB. So I need to make sure that whatever that I do, I bring the AB to the party, because the AB is the one that will bring me that tan y. I think it's easy if you analyze it like that. Let me try to repeat this. Let me try to repeat this. What I'm saying is that I have this x. I need x. Then I chose a triangle that has x. So now the next thing that I'm going to ask myself, the tan y, where can I get tan y? I already have the tan y. And to bring it, I need to include AB. So whatever that I do, we need to bring that AB. Okay, everything is good now. But now I have an equal sign. How can I bring an equal sign on my equation? The sign rule. So the only way we can bring this equal sign here is the sign rule. So this tells me that if we use the sign rule, we're going to use the sign rule in triangle ABC. We're going to use the sign rule. So when I use the sign rule in triangle AB, this is what I have. I'm going to say I really need that that angle. So I'm going to say this will be the, on top I'll have the sine. Hey, you see now, guys. Let me do this. Let me start by bringing B. Let's bring B first. Let's bring the B, the AB first. So we know that if this line is equal to that line, this one is also x, because if I use this, 2 angles are equal, and then I can use that AB because I need AB to make things work. So now I'm going to say the sine of angle C over AB. Now that I have that, I can choose which other side I can use, So now the best way to work on this, I think if we can use the BC and use that angle. What is that angle equals to? Remember, this will be 180 minus the sum of these 2 angles. So sum of angles in a triangle, this is x, so it will be minus 2x. So what I'm trying to say is that angle A will be equal to 180 degrees minus x with minus x, which is just the same as 180 minus 2x. That is that angle. So this will be my small a. So on top, I'm going to have the sine of angle A, everything divided by BC. So let's work on this. Let's just do the substitution. Let's substitute what we have. The sine of angle C is x over AB. What is AB? We calculated AB to be P over tan y. So I'm just going to put this and say this is P over the tan y. Equate this to the sine of angle A, which will be the sine of that angle A. We said it's 180 degrees minus 2x. Everything is divided by BC. What is BC equals to? What is the length BC equals to? I think it was given that AD BC is 2 times AD. So what is AD? AD is given as P. So this tells me that BC is 2P. This will be BC because AD we know is P. So BC is just 2P. Now I'm just going to substitute that as 2P. I hope everyone understands where is the 2P coming from. Oh, there's too much work. There's too much work, but let's keep on working. Okay, so this part I'm just going to leave this as the sine of x over P over the tan y, and then I'm going to equate this to, so this is in quadrant 2, sine is positive, this will be positive, the sine of 2x, everything divided by 2p. This is what I have so far. Remember, if I have A over B, everything divided by C, I can change this using the fraction and say this is A over B multiplied by the reciprocal of C over 1, which is 1 over C. So what I'm trying to say is that we can change this sine x over P. We can say this is the sine x. Remember, the sine x is the one that is over 1. We can multiply this by the tan y will come on top. Then we divide this by P. Then we equate this to the sine 2x over 2p. Okay, so far everything is good. Now we can just write this as 1. What can we do? We can just write this as, change the sine 2x, maybe we can write it as 2 the sine of x, the cos of x, and everything is divided by 2p. Now this other side, I'm not sure what I'm going to do with this one, but the tan y, I need it to be there, so I'm just going to leave it like that. So I'm going to have this as the sine x, it's multiplied by the tan y over p. I hope I'm not making this to be more complicated. The 2 cancels. I'm just trying to get something that can cancel, but I already see these 2, that this 2 and that 2 will cancel. And then what's next? We can cross multiply, right? We can cross multiply by this p. We can get rid of the p and say this is the sine of x multiplied by the tan y over p. Everything here needs to be multiplied by p, and then even this side we still have the sine x, the cos x over p. We need to multiply this by p so that the p cancels. This side we only have the sine x, the cos x. This side the p cancel, and we have the sine x, the tan y. So I can see, if we go back to the question, they want us to prove that cos x is equal to tan y. I'll just have to eliminate that sign. I can just divide this by sine x. I can just divide this by the sine x. Therefore, left hand side, which is tan y, is equal to the cos x. We've managed to do the proof. I'm happy about that. Next, I'm happy about that. I am very happy. I don't want to lie. I am very happy. So how many marks? This was 4 marks, but my problem is that how are you going to think about maybe you miss this statement, the 2p, because remember I said I'm not interested in reading the statement. But look at now, we did not read the statement. Then when I substitute this, I see that no man, BC, there's no way we need to calculate BC, and this is 4 marks. I went back to the statement, then I see that I missed something on the statement, which is that BC is twice AD. So if we did not pay attention to that statement, everything, we were going to struggle to calculate this question. But it's fine. Let's see what we have on the next question. 8.3. I don't know if there's other method that we can use to do this. I don't know. I don't want to lie. I don't know if there are other methods. But look at this 8.3. They say that if x is 60, calculate the size of y. I'm just going to work on it down here. If x is 60, we are given the value of x to be 60. Say at the end, y divides sine x. Okay, someone is asking, why do we divide sine x? Remember, the question wants us to prove that the cos x is equal to the tan x. So the aim is to remove everything and leave this as x, this side. So this side, we only need cos, you see. So if I can just quickly rewrite this, I have the sine x, the tan y, because someone is asking on the comments, why are we dividing by sine x? So this will be the sine x, the cos x. Look at this. I need to have this and this. So I need to get rid of sine. I can just divide both sides by sine, because we need to remove those guys, so that we can only be left with tan and cos. So this will be tan y is equal to the cos x. Where did the cos x net come from? 2 sine. Angle, I'm not sure if I'm saying your name right, but please tell me, which grade are you currently doing? Before I explain this, can you please quickly comment, which grade are you currently doing? Before I can assist, please tell me, in which grade are you? Course next. Tell me the grade, then I'll be able to assist you now. I just want to understand, which grade are you currently in? Are you doing grade 11 or 12? Grade 12. Okay, then I can explain this to you now. You see this, you are asking where the cos x, where did the cos, let me show you this part here now. It's a double angle for what? It's a double angle for sine. Yeah, it's a double angle for sine. So what I'm trying to say is that where the sine 2x, we can replace this as what? 2 the sine x, the cos x. I hope this answers your question. So this was the identity. Ne? This was the identity. So what we did is that we worked on the identity. It was just an identity. Ne? Sure. Okay. I see your comment that you say, you see now, this tells me that you understand. Ne? Remember, we just, to work on this 8.3, we just proved that the cos of x is equals to the tan y. And they tell us that x is 60, we need to calculate y. So this will be the cos of 60 degrees. It's equal to the tan y. So where there's cos 60, we need to punch that on the calculator, né? And I think it's half. Let me just verify. This is the cos of 60, it's half. So 1/2 is equal to the tan y. Therefore, what is y equals to? Y should be the tan inverse of that half. So shift tan of 1/2, what is that equals to? This is 26.57 degrees. So therefore the value of y is 26.57 degrees. I think this is where we should pause and see if there's someone who has questions. Please guys, if you have questions, now is the right time to ask, né? Please make sure that you bring those questions. Let me answer your questions, né? Is everyone happy? Do you guys understand how we solve this one? Because now we'll move and do another past paper. We'll move and do another past paper, but I need you guys to comment and tell me if you are happy. Then we can work on the next one. So say, I see there's a question. Okay, I see there's a question. So say, for 8.3, technically we didn't need to solve 8.2 to get 8.3. Since the question was a proof question. Yes, we don't, even if you get 8.2 wrong, you still have a chance to work on 8.3 because it was a proof question. We already know that the cos x is equals to tan. So what they were supposed to do is that they were supposed to say hence or otherwise show that the size of y, if x is 60, calculate the size of y. Hence or otherwise calculate the size of y if x is 60. That's how maybe you should expect the question next time, né? I think so. I think that's how we should expect the question. Thank you, Nube, for sending your question. So I see other learners, they don't have any question. Let us move, né? Let's move. Let's go and find another past paper. We were on 2025. Now let's move to November 2024. Let's see how this question is asked. Okay, paper 2, English. Okay. Okay, let's see what we have here now. On this question, let's see what we have. We're still working on 3 dimensions. So this is just 2 questions. I think we're just gonna work on this one first, né? I'm just gonna try and see on the statement in the diagram. They say C. In the diagram, C is the foot of vertical building and D is the top. Okay, I'm not interested in the statement. I know that they just saying this, but if we see that something is not working, I'll go back to the statement. But I'm not encouraging you guys not to read the statement. Please make sure that you read the statement. But on my side, to save time, I'm not gonna go through the statement because most of the time, whatever that they put on the statement, They're just telling us what we see on the diagram. Calculate the length of AC, the distance between the observer at A and the roof of the building. So the calculate, you see now, I'm just going to leave the fancy weights and focus on my AC because I know that I need to calculate AC. So they just want us to find AC. So this tells you that the observer is standing at this point and another observer is standing at that point. Right, they want us to find what are we looking for. Let me do it like this. They want us to find the length of AC. So in which triangle it's AC? That's where you start, you see. So where is my AC? This is my AC here. So now AC, it's a common line of two triangles. We need to choose the triangle that will work. So I'm going to take this one because we have that as 16 and this is a right angle triangle, and looking at the mark allocation, this is just 2 marks, so we can use the SOH CAH TOA. Okay, we can use the SOH CAH TOA to answer this question. We're going to work on it, don't worry guys, we're going to work on it step by step. Okay, so what I'm going to do, I'll say that I have my opposite and I'm looking for adjacent. So this tells you that we need to go for tan of that angle. So this will be the tan of that angle. What can we call this angle? Because I don't want you to get stressed if I call this angle CAD. This is equal to opposite all over adjacent. So the tan of that angle that we are referring to, it's 46.85. So this is 46.85. Let's equate this to opposite, which is 16 over adjacent, it's AC. We are looking for that AC. I can just remove the fraction first by multiplying both sides by AC, multiply the other side by AC. Therefore, AC, the tan of that 46.85, what is this equals to? Is just 16. Then divide both sides by that, we're going to get our AC to be 16 over the tan 46.85. You punch that on the calculator, you're going to get your length of AC. Okay, so on my side, when I put this on the calculator, this is 16 over tan 46.85. I have my answer as 14 point something. I'm just gonna try to run off this. This will be 14.90. I'm not sure, but we are working with the weight. Let me go back and see what is the statement saying, the instruction of the question paper. If necessary, round off your answer to 2 decimal places unless stated otherwise. What they said on the question, they said the distance between the observer. So there's no other instruction, but we're just gonna leave this into 2 decimal form. This will be 14 point, but if it's 14.998, if we round off this, so AC is just 15, so this will be 15 meter. So that's the answer for AC. Then we are done solving that question. This was easy. I think this was very, very, very easy. Nah? Easy question to work. Okay, that was 2 marks, but look at this one, 7 marks. Yes. Calculate how far the painter at E is from the top of the building. Yes. Guys, look at what you need to do here. Nah? So we can first find they want the length of AC. So we are looking for the length of that AC. We are looking for the length of that AC. What is that AC equals to? Okay, I think the first thing that I can do, we need to look at this. Now we can use the theorem of Pythagoras, or we can just, I'm not sure guys, but what I think is that if we can get this side, if we can get BC, if we can first start finding BC, and then when we have BC, we can use the trig ratios. We can use the trig ratios to find the length of, that's the only way to solve the problem, because what I'm trying to say, if we find the length BC, if we find this BC, then we'll be able to find that one using my opposite and my adjacent. So this will be tan, but we need to first find BC. And when I see I have AB, which is AB, okay, and we just calculated AC. Okay, I have this line and I have that line. So in order for us to use SOH CAH TOA, which angle should we use? Because we're going to say this line and that one, so we're not gonna use AB, okay, let me do it like this. Hope you guys won't be angry with me. Now this will be small c, this will be small a, and this will be small b. Look at this. I'm looking for BC, so I'm just gonna use the formula rule and say my c squared. Where can I write this? Okay, I'm going to write this like this and say my c squared, small c squared, is equal to small a squared plus b squared minus 2ab, the cos of, which angle are we using? This angle here, because we are using a small c, we need to use the included angle. This will be B angle CA. So if we substitute, we know that the small c is AB. So this will be AB, and this is squared, it equals to small a. What is small a? Say, why EC? Did I mention EC? Did I say anything about EC? Oh, EC, look at this. They say calculate how far the painter at E is from the top of the building. So we know that the top of the building is 16. So if the top of the building is 16, what we can do is that we can quickly find the length from maybe C to what? C to E. This is what they are looking for. They are looking for this one at point E, the length of the building at point E. So that's why we're going to calculate the length of EC. But we can't do that if we don't have BC. We need to first start finding the length of BC. This is what I'm currently working on. So my small a, it's BC squared, plus my small b, it's AC. So this will be AC, which is squared minus 2 into BC into AC. Then this is the cos of that 105.61 degrees. Okay, easy. So let's substitute AB, it's 90 squared. We are looking for BC squared. So maybe we can just, okay, we are looking for BC plus AC. We just calculated AC to be 15. Remember, we just calculated the length of AC to be 15. So this will be into 15 squared minus 2 into BC, which is what we are looking for. And then I'm going to say this is AC, and AC is 15. The cos of that 105.61 degrees. Okay. So now I just have to isolate this, and the best thing to do, can we let BC maybe to be any variable? I can say 19 squared is equals to BC is K squared, and then we're going to minus, okay, plus 15 squared minus 2K into 15, the cos of 105.61 degrees. What's next? 19 squared. What is 19 squared equals to? I get 361. So this will be 361 is equal to K squared plus 15 squared, that's 225, minus 30K, which is multiplied by, guys, can we just say 2 times 15 times the cos of that, né? We can say this is 2 multiplied by 15. We multiply that by the cos of 105.61. Therefore, we get the answer as negative 8.07. I hope no one is lost on that part. I hope everyone is still with me now. So this will be negative, we're going to minus this as 8.07, 8.07. Guys, this is wrong. This is wrong. This is so wrong. We're going to take the negative 2. So if we take the negative 2, we multiply that with the 15. This will give us positive 8.07, because we are saying this times that. Then we still have the K there, and then yeah, that's it. Now we can focus on making everything to 0. So this will just be K squared, and then the 361 comes to the other side to be negative. So this will be plus 8.07K. Then I need to subtract 361 from what? From 225. Yeah, this gives us negative 136, and this is just 0. I don't know how to factorize this. The only thing I can do is to use the quadratic formula, né? Because that's the only best thing we can do, using the quadratic formula. So when I use the quadratic formula, I'll say that x is equal to minus b plus or minus the root of b squared minus 4ac, everything divided by 2a. So I think we need to say x is equals to negative inside the bracket. The value of b is this one. So this will be 8.07 plus or minus the root of b, which is 8.07, and this is squared minus 4. The value of a is 1, the value of c. Guys, this is a sign where we are tired. Okay. Just gonna try to make everything fit, né? So this will be x, it's equals to negative inside the bracket 0.8.07 plus or minus the root of 8.07 squared minus 4 into 1 into C is negative 136. There we go. Thank you. So everything is good now. This is 2 into 1. We just have to punch the calculator. So let's see what you guys get. When you put this on the calculator, what do you guys get? Method, you just have to apply what you know. Even though we're working on three-dimensional, you can see now we are factorizing quadratic. So this tells you that algebra is the motherboard. You need to understand algebra to master most of the questions. So I'm just gonna put this on the calculator. This is minus 8.07. So okay, I'm going to attend your question just now. Let us finish with this one. 8.07 squared minus 4 into 1 into minus 136, everything divided by 2. So we get okay, I got my answer as 8.30 x, okay, not x. K is equal to 8.30 or K is equals to, so I think the other answer we're going to get a negative, which is the one that we need to reject. Exactly, this one is negative 16.38. Therefore, we're going to reject this one because remember, K is BC. K is BC. The length can never be negative. So we're going to conclude and say our BC is equal to 8.30. That is the BC that we need to use to find EC. So I'm just going to attend Ngube is saying, what if you used the sine rule to get the angle of B? Use the sum of triangles to get the value of angle C. Use the sine rule to get side. Then you say 180 minus 115 to get angle E. We are not looking for angle E. We are looking for the length of EC. Ne? We are looking for the length of EC. But yeah, maybe you are saying if we can get angle E. No. We are looking for that side. Now that I have BC, I know that I just calculated my BC to be what? 8.30. I can say I have adjacent, I have opposite. I can use the tan of that angle. So now we also, wow, we need to get that angle. What is that angle equals to? Oh guys, exterior angle of a triangle. Look at this. Look at this. Now we need to apply the exterior angle of a triangle. Remember, this is 90, and if I have a triangle like this, and this angle here is the sum of this plus that. So what we are trying to say is that when we take, let's call this theta, and then when we take theta, we add it with 90, we need to get 122 degrees because it's an exterior angle of a triangle. You'll give them the reason on your answer sheet. It's the exterior angle of a triangle. Please make sure that you get this right. So angle theta will just be theta is equal to 122 degrees minus 90. So we're just gonna say 122 minus 90, and what is this equals to? 32 degrees. So theta is equal to 32 degrees. So if I have theta as 32 degrees, this is my 32 degrees, then I can definitely say, what is this? What do we get here? we can say the tan of that 32 degrees is equals to opposite, which is EC over, the question said we need to how far the painter at E is from the top of the building. So it's going to be EC over adjacent of 8.30. Right. So EC is just 8.30, the tan of 32 degrees. You just have to punch that on the calculator and you'll get what is EC equals to. So we get our answer as 5.19. 5.19. But remember, we know that this side here, it's 5.19. That's the length. It's 5.19. But the question is asking how far the painter at E is from the top of the building. How far? If this person is 5.19, how far is the person from the building? So what they're asking is that how far is this distance here from E to D, and we cannot find E to D if we don't know what is EC equals to. So to find E to D, we know that DC it's 16. It's 16. So DC it's 16, and then now we know that EC it's 5.19. So to find the length of DE, DE will be equals to, we need to take our DC, we subtract our EC. The answer that we get is the answer that they are looking for, 16 minus 5.19, and what is this equals to? 16 minus, we get this as 10.81. So this is 10.81. So when they ask how far is the observer, okay, they say how far is the painter at E is far from the top of the building. So this at E, it's 10.81 meter away. Okay, so I meant we calculate angle E, then we use side C and tan to get EC. Angle E. Ooh, but now we don't have, remember that the aim is to have, yes, even if we do that, that was going to work if we had maybe one side, né? Because we can find this angle here. You are right, we can find that angle using angles on a straight line. I agree with you on that. But looking at this problem, we don't have any other sides. But otherwise, I'm happy that we've managed to answer all the questions on this paper. So we're going to continue, guys, with the lesson. We'll do more past papers, don't worry. We just have to move to the new topic, and we'll see what we're going to do. Maybe on our next one we can start with this one, especially since we are trying to accommodate those who are going to rewrite. Maybe we can do Euclidean or analytical geometry. I don't know, we'll see. Né? We are done with trigonometry. We did everything on trigonometry, and I believe that everyone is ready for this question. And then the other thing that we've covered is this one. If you have not checked the module on this one, drawing the triangle, then yeah, you need to go and watch that video. I think everyone see the pattern that I'm trying to create here. Let me show you guys. When we start, we worked on this one, how to answer question 5. So now everyone is ready with question 5. Okay, everyone is ready with question 5, and then now I did help you guys how to work on question 6. Everyone is ready with question 6. If you did not miss any lesson, and if you did watch the previous recordings, and then now when we move to question 7, we haven't done trig graphs, but we're going to work on them. So far everyone is happy with 8. Everyone is ready for question 8. Né? So if we go back to analytical geometry, everyone is ready for question 3, because most of the time question 3 has to do with grade 11's work. everything that you see is grade 11 most of the time. Then the grade 12's work, you're going to get it on question 4. This is what we have been covered. So look at this. According to me, we've covered close to 60% of paper 2. So you see now why is it important to make sure that you always attend, because we are busy working on something. We are busy working on something here. You are ready for question 3 of the paper 2. You are ready for question 5 and 6 and also 8. I don't even want to talk about paper 1, but thank you guys for joining in. This is where we're going to stop. Remember, our life only goes for 2 hours. Ne? We started 1:30 and we are ending the lesson now at 3:30. Thank you guys, and hopefully I'll see you later today on our next lesson. This is where we're going to stop. Ne? Thanks. Oh, yes.